The thing is, these babies are not born yet. ठीक है, these babies are not born yet, and this is something कि ये फैमिली में जो बच्चा होगा उसको बिफोर दे आर बॉर्न, जब तक उसको एक एक्चुअल नाम नहीं दिया जाता है, आई विल कॉल दैट बेबी एज F1. Similarly, I'll call this baby as F2. Just a sec. Someone joined. Okay. Hi Vanshika. We were discussing maximum likelihood estimators. We are going to discuss MLEs. But before that we were discussing कि वो capital X और small x में क्या फ़र्क पड़ता है. तो quickly recap. Let us assume that there are 5 families. Each of the families are expecting a baby, and all the babies will simultaneously be born on 31st of December. Before each one of these babies are born, I just call each of them as F1, F2, F3, F4 and F5. So this is not the actual name of the baby. I am just, मतलब वो प्लेस होल्डर जैसा है कि ये जो भी बच्चा होगा उसका अभी तक का तो कुछ नाम नहीं है. So let's just call this baby F1, this baby F2, this baby F3, this baby F4 and this baby F5. So these babies are not born yet. The moment they are born, the families give them a baby. So let's say whatever this F1 baby was, उसका नाम रख दिया गया आर्यन, इसका नाम रख दिया देवाशीष, इसका नाम रख दिया यश, this is तुषार, this is Ruby. Okay, so right, so now these FIs have some concrete value attached to it. I won't refer to the baby born to the family F1 as F1 anymore. I'll say कि आर्यन, उस बच्चे का नाम आर्यन है, इस बच्चे का नाम देवाशीष है, इसका यश है, इसका तुषार है, उसका रूबी है, राइट. So these are kind of realizations of the random variables. And these are basically generally written in small case, and random variables are written in uppercase, right? So this is essentially the difference between, you know, uppercase and smaller case. So now let's take a like statistics wala example कि I am going to take, let's say I have a farmland and I am growing, let's say, some flower. Okay, so I am growing some flower and I have ऐसा एक सेकेंड, I have बहुत सारा ऐसा flowers लाइन से, and this. Okay, let's just get rid of these. So this is my farmland and these are my flowers. Now there are बहुत सारा ये जो भी ज़मीन है इसमें बहुत सारा ऐसा फूल है. By the way, सबको हिंदी आती है ना? I mean, I'm assuming कि सबको हिंदी आती है. Anyway, so this. Now I am a statistician. What I am interested in the size of this petal. So thing that I, that is the statistician, is interested in is basically the petal size of these flowers, right? So petal size of flowers in Yash's farm, right? So this is what I am interested in. So what I do, I cannot go and measure each and every one of these flowers ka petals, right? That would be way too time consuming, exhausting, or in some cases it is that's not feasible only. ठीक है, मान ले ये कोई I am not talking about flowers in a particular farmland, I am talking about flowers of a particular species. तो अब वो स्पीशीज का फ्लावर दुनिया में कहाँ कहाँ है, कहाँ कहाँ नहीं है, आई कैन नॉट गो एंड मेजर ईच एंड एवरी वन ऑफ देम, राइट? सो आई नीड टू टेक अ सैम्पल. सैम्पलिंग के सिवाय और कोई ऑप्शन है नहीं मेरे पास. सो व्हाट आई डू, I go out there and I collect my sample. Let's say I collect a sample of I collect a sample of five of these flowers. ठीक है, 1 2 3 4 5. Excuse my drawing skills, but this is the best that I can do. Anyway, so I collect these ये मेरा sample है. ठीक है. Now what is, so this is, so I collect this randomly, so this becomes my, so I am doing my sampling, and what I get is a random sample. So this is my random sample, right? Now what was I interested in? I was interested in the petal size. So what I do, I define x to be a random variable I define xi to be a random variable. ठीक है, and where xi denotes the petal size of ith flower, right? So okay, now assume that कि ये जो sampling वाला चीज था, I have not done it yet. Okay, I have not gone to the farmland, I haven't seen the farmland. Let's say I am in my office, I am in my statistician का office, and मेरे को ये survey करना है. So before going to the farmland, I decide कि I am interested in the petal size, and I am defining a random variable xi to be the petal size of the ith flower, and I am going to, let's say, collect a sample of and I will collect a sample of size n. Okay, so before going to the farmland, before actually going to collect these flowers, what I know that at the end of the day I am going to have something that looks like this: x1, x2 till xn, right? Where x1 will denote the petal size of the first flower that I draw, x2 will denote the petal size of the second flower that I will draw, and so on till xn. xn will denote the petal size of the nth flower that I get. But I still haven't went out there and collected the data. मेरे पास अभी जो भी है ये काफ़ी abstract है, and I am going to denote this in capital letters because x1, x2, xn, they are not numbers, they are merely aliases, right? So they are not numbers, they are my random variable, and together ये if I collect these random variables together, I'll get my random कौन सा पार्ट? तेरा आवाज कट गया, और एक बार बोल. वाह भाई, चाय लेके बैठा कर, चाय लेके बैठा कर, तब जोन आउट नहीं करेगा. हम भी चाय पी रहे हैं मस्त. एनीवे, बेसिकली कि तू अभी तक का गया नहीं है, यू हैवंट सीन दिस फार्मलैंड, तो ये फार्मलैंड गया नहीं है, तो ये बगिया गया नहीं है. बिफोर गोइंग देयर you define a random variable xi, and xi will denote the petal size of the ith flower, ठीक है, और तेरा sample size n है. तो at the end of the day you know कि तेरे पास ऐसा एक collection होगा x1, x2, xn को लेकर, ठीक है, where x1 will denote the petal size of the first flower, x2 will denote the petal size of the second flower, xn will denote the petal size of the nth flower. but these are not numbers, these are हाँ, so इन सबको साथ में लेंगे तो दिस इज माई रैंडम सैंपल, ठीक है, बट x1 x2 xn these aren't numbers yet, ठीक है. अभी वो बस लाइक जस्ट लाइक दिस राइट, कि ये f1 f2 f3 दे आर नॉट नेम्स. हमको पता नहीं है कि वो बच्चा का क्या नाम होने वाला है, इसलिए जस्ट फॉर द टाइम बीइंग आई एम कॉलिंग इट एज f1. आई डू नॉट नो what exactly this family is going to name their baby. Similarly, I don't know what the petal size of the first flower is going to be. It can be 5 millimeter, it can be 6 millimeter, it can be 20 millimeter. I don't know. So for the time being, I am just naming them as x1, x2, xn. I don't know what that is yet. Okay. Now what I do after doing all this, then I go to the farm. I go to the farm and actually collect data. ठीक है, then I go to the farm. तब हम यहाँ पर गए, I pick, let's say I pick this one, I pick this one, ऐसा करके I pick a few. I got n flowers out of that farm and I measured the petal size of each one of them. And what I got, let's say I got 5 millimeter, 6 millimeter, 17 millimeter, 3 millimeter, and so on. And let's say the last one was again 6 millimeter, let's say, right? So these are numbers. And what is this? This is the realization of my, or even better, this is the observed random sample. This is the observed random sample, and these are numbers, right? And I would denote them in small letters. So this would be my small x1, this would be my small x2, this would be my small x3, this would be small x4, and this would be my small xn. So this collection x1, x2 and so on till xn, this is basically a vector of actual numbers. I mean, it is not necessary कि हर time ये number होगा. So for instance, in this case, I was going and collecting the name of the babies. So in that case, the observed random sample is not numbers, but you get the point. कि these are actually the things that I want to collect. These are not aliases, these are not functions, these are actual objects. In this case, this is actually the size of the petals. And what was this? This was just kind of it is, so you can think of random samples as the temporary name that you give to whatever that you are interested in. And when you go out there, you collect the data, you have actual concrete data. Then you call them the observed random sample, and then we denote them using small letters. So we would also, we generally kind of write, right, ki let x1, x2 dot 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 xn be a random sample, and right, and we often write ki what is the probability that x1 takes the value small x1. ये बोलने का मतलब क्या है कि क्या प्रोबेबिलिटी है कि the petal size of the first flower will be equals to some number. So this is some number, right? So this is equivalent to writing as कि क्या probability है कि जो पहला फूल का जो petal size होगा, that is going to be, let's say, 5 millimeters, right? So this is kind of equivalent, but we don't work with like numbers, right? We work with symbols, क्योंकि we are, मतलब समझ रहा है ना कि when we are talking about some generalized stuff, so इसीलिए we write it as x1. So That is the difference, right? So you can kind of, so yeah, so basically these are like functions. Okay, these are not numbers, these are functions. Random variables are functions. These are functions. These are real valued functions of something, right? And it doesn't kind of, it doesn't make sense to kind of talk about but let's leave that. So point being, these are functions, and these are not functions, these are concrete numbers or whatever that is that we are interested in. So these are concrete objects, these are not functions, these are something that we have observed. So that is why this word comes in, right? So observed random sample, I have went out there and I have observed this has happened, and these are just functions. So is this distinction clear now? कैपिटल एक्स साइज और स्मॉल एक्स साइज में, ठीक है? एवरीवन एल्स, पीली जिदिश पॉइंट, we'll take that as a yes. Now moving on to the next thing. So now that we are clear about what kind of random variables are, or random sample is, now let's, so our essentially the thing is we want to talk about this, right? So we want to talk about estimators. So what exactly are estimators? Now so always keep, okay, so this was all about, random variables. Now let's talk about estimators. So before getting into what are estimators, there are certain terminologies that we should be familiar with. First is a parameter. Second is a statistic. Third, is there a third? Then basically there is estimator. There is an estimate, and I don't think there is anything else. So these four terms are, if you haven't, or if you do not know them, or if you have a very vague idea about everything, then this is very confusing. But once you get it, it is very easy to distinguish one with the other. And it is very, 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 very important to always have at the back of your mind what these four things actually are. Parameter, before actually defining what a parameter is a number, or it's the cases that we are dealing with, or parameters are constant. That is a better way of constant spelling, constant. Parameters. So before even getting to know what exactly parameter is, one thing that you should have ingrained in your mind, that parameters are constant, they do not change. Other thing to know about parameters. So first thing, they are constant. Second thing, they are unknown. You never know what the parameter is. If we knew what the parameter was, then there was no point to statistics, reading statistics, studying statistics. कोई point नहीं बनता है. And the whole reason why we have this big root का पूरा book, econometrics का पूरा course, is because parameters are unknown. We can only make guesses about parameters क्या हो सकता है. We never truly know कि वो क्या है with 100% certainty. What is a statistic? Statistic is not a constant, it's not a number, it's a function. Function of what? We'll get to it. What is an estimator? Again, it's a function. What is an estimate? Again, this is a number or a constant. So ये हमेशा रहना चाहिए कि statistic and an estimator, they are functions, they are not numbers, they are not cars. They could be cars, no, they are not cars, they could be, they are just functions. Estimate is the output that you get when you put something in this estimators. Okay, so before even getting into all of this, keep this in mind. Parameter constant है, unknown है. Statistic is a function, estimator is a function, estimate is a constant. Now to actually define, or to actually explain what this parameter, statistic, estimator, estimate is, consider this example. Ki this is my, yep, this is a better circle. This is my population, okay? This is my, okay, let's not do this. This is my, let's say, population of populations of what? Suggest heights, population of people. Let's say population of people. So दुनिया में possibly पूरा यूनिवर्स में जितना भी इंसान है, all of them are contained in this set. That is called population. We are talking about people, but it can be anything, right? So population of tigers would be all the tigers in this entire world. Population of phones would be the set of all phones that are there in the world right now. So it is anything. When we take a subset of this population, what do we get? Anyone? Any idea? Right. So this is a particular sample of people. Right? Now, this entire population has an average. Right? So let's say we are talking about people's height. So this entire population has an average height, and that is going to be, let's say, mu. Right? Just a sec. Oh, Vanshika texted me. I did not see. Sorry, I didn't see your text. Okay. लीनियर अलजेब्रा का प्रॉब्लम सेट 2 भी आ गया है क्या? बाद में देखेंगे. Anyway, so this entire population is a, okay, so acha, parameter is a constant, yes, but it is also a function. Okay, I'll get that to later. Anyway, so this population has an average, so this population of all the people, they have an average height. Let's call that mu. Okay. Similarly, sample is going to have a height. Let's call that average height of this particular sample. Okay, average heat हो गया है. Average height. Let's call this small x bar. Now, this, this mu won't ever change, right? This mu won't ever change because it is, so let's say, so before mu changing, let's say this was one of the samples that I took, right? If I take another sample, let's say this is sample 1, this is, let's say, sample 2, दिस इज गोइंग टू हैव सम अदर मीन. कोई गारंटी नहीं है कि ये x बार और ये x बार सेम होगा, राइट? सो माई sample mean, let's call this small x1 bar, small x1, small x2 bar. There is no guarantee that x1 bar is going to be the same as x2 bar. They can change, most probably they will change as I change my samples. So this sample mean is a variable, it is not a constant. Whereas what about this population thing, population mean? This won't ever change, right? Because it is practically impossible to consider another population of people, because this population people already consists of all the people, है ना? So it is impossible for me to kind of change the population of people. So this won't ever change, mu won't ever change. Now in this case, mu is our parameter, and this small x1 small x2 bar, this is our statistic. Now why do I say that parameters are unknown? Parameters are unknown because you won't ever, no matter what you do, you will never be able to estimate, or you will never be able to determine the average height of all the people in the world in a given instant, ever. Because let's say if you start calculating the average height, the moment you are done with everyone in India, there are going to be some people who die, there are going to be some new babies who are born, and your population is ever changing. It is practically impossible to ascertain this average height of all the people in this world. So you will never ever be able to determine what this mu is. It is just impossible. But what we can do is we can make guesses about this mu, right? So parameter will never know what this is. But we can make guesses about this. Now, how do we make this guess? Literally, I can make any guess, right? I can just say, I don't care what the population is, my guess will always be 50, my guess will always be 60, my guess will always be 70. So I am free to make any guess that I want. By the way, if any of this is repetitive to any one of you, या फिर अगर सभी को ये like पता है, तो you can just tell me, I'll just skip this portion because हाँ
इसमें हम लोग मतलब वो पता है कॉन्फिडेंस ऐसा कुछ था you take 90 or something, ठीक है, and if the confidence level is 95 or something like that, तो ये होता था कि that average of all these samples it will convert to, yeah, it will be equal to the
that is kind of, you are talking about essential limit theorem. We'll get to this. So I'm trying to go there only. So the thing is, I can make any guesses about this. I am free to make any guess. मेरे को कोई फर्क नहीं पड़ता है. Now I don't want to make any guess about this. I want to make guesses that might be correct or that are correct with a very high probability. So I need to come up with a guessing scheme which is better than randomly guessing. So what I do, I go out there and then I collect my sample. Okay, sample collect किए, I calculate this average of the sample and then I say कि ठीक है, I guess कि population का average और sample का average करीब करीब होना चाहिए. So if this turns out to be, let's say, what, 5 feet, I am guessing that population का भी height is around 5 feet. Now that is a guess that I am making. ये जो x bar है, okay, so the basis on which I am making the guess. Okay, by the way, none of this is official definition. I would strongly advise each and every one of you to go and look at the actual definitions of what a parameter is. If you go and look, they will say that it is a function of population values, राइट कि ये जो मीन मिलता है वो हर एक का हाइट लेकर के इफ आई add them up and then divide by the population size, then I'll get this mu. So mu is essentially a function of population values and it's a constant, it will never change. Similarly, statistic, they will say that this is a function of sample values, right? So ये जो sample है इसमें से let's say I take the height of every person, I multiply it by 2 and then I add them up, then I divide by 1000. Whatever that I get, that is a statistic. Anything that is solely a function of sample values is a statistic, right? So I take the height of every people, I square it, then I cube root it, then I raise it to the power of 1000, whatever that I do with these sample values, it is going to be a statistic, right? Now the statistic that we use to infer something about the population.
Smallest वाली है ना, smallest वाली मैं बहुत डाउट में रहता हूँ ये smallest वाली मतलब are we observed or not?
See, again वो depend करता है, but for the time being I'll in this context keep everything मतलब अलग अलग रख. So this x1 bar, this is although it is written in small notation, but this is a random variable. अब वो depend करता है, right? कि have you actually observed this, have you actually went out there and then have you collected the data and then have you calculated it? If you have calculated it and then this is x1 bar, ये जो number तेरे को मिला, then it is not a random variable, then that is a constant, that is the realization of the random variable. But if you are talking in abstract terms कि अभी तक का हम जानते नहीं है, उनका data collect नहीं किए हैं, then x1 is a random variable because it is, क्योंकि इस पर्टिकुलर सैंपल में x1 बार है, इस पर्टिकुलर में x2 बार आएगा, सो दिस विल चेंज, राइट? सो इट डिपेंड्स कि तू कौन सा कॉन्टेक्स्ट में सोच रहा है, दोनों हो सकता है. सो इन मोस्ट ऑफ द केसेस व्हेन यू रीड द क्वेश्चंस यू काइंड ऑफ नो कि व्हाट दे आर टॉकिंग अबाउट. So the thing that I was trying to say was that the statistic that we use to infer something about the population parameter is known as an estimator. Right? So I am using my sample mean to guess or to estimate the population mean. So sample mean is the estimator for population mean. If I was using, तो मैंने ये बहुत ही absurd sound करेगा, but if I am using sample standard deviation to infer something about the population mean, कि मान ले standard deviation आया मेरा 5 का, अब on this basis हम बोल रहे हैं कि average height भी 5 होना चाहिए, which is absurd, but it is still a valid estimator. It is not the best estimator, but it is still an estimator. So, and estimator is again, right? So since statistic is a function, estimator is also a function, because a statistic and estimator are essentially the same thing. Context के ऊपर depend कर रहा है कि हम किसको क्या बुलाएंगे. If I just have a function of sample values, I have a statistic, and if I am using that statistic to do some inference, तब that is a estimator है same चीज. Now a particular value of that estimator is an estimate. So was all of this clear कि estimator क्या है, estimate क्या है, statistic क्या है, parameter क्या है? Right. So okay, now the next question that we might have is like I said, right, कि standard deviation भी use कर सकते हैं estimate करने के लिए, sample mean भी use कर सकते हैं estimate करने के लिए. तो what to use? Now if we are not mad, पागल वगैरह नहीं है हम लोग, तो we want to kind of make the best guess about this population parameter, right? We want to be as close as this, we want to be as close as we can get to this population parameter. So we want to make best guesses about the population parameter, right? Now how do we make the best guess? There are again a couple of philosophical things. So there is one criteria which is known as the guess which minimizes, so the guess that minimizes the squared error, राइट कि अगर हम जो हम प्रेडिक्ट कर रहे हैं और जो एक्चुअल वैल्यू है उन दोनों के बीच में जो डिफरेंस है और उसको अगर हम स्क्वायर कर देते हैं, दैट इज नोन एज स्क्वायर्ड एरर. सो एक ऐसा केस जो स्क्वायर्ड एरर को मिनिमाइज करेगा, दैट इज माय बेस्ट केस. द अदर थिंग इज द गेस दैट मिनिमाइजेस द एब्सोल्यूट एरर, दैट इज माय बेस्ट केस. Then comes the guess that maximizes the probability. Okay, pretty sure I wrote this wrong. Probability of observing the sample that we did observe. ये थोड़ा vague है but I'll explain. Is the best guess. Then that is the best guess. The other thing is basically the same as the above, almost same, and I already know some more things or some additional information. I know some additional things about the parameter, and I incorporate them. Wait, this is not a good phrasing of everything. Just a second. So basically, one other philosophy that is very frequently used is this: कि the guess that will maximize the probability of observing the sample that we do observe, given the fact, given something else. Okay, I'll explain what each and every one of this means. Given some additional information. So I guess so. This is something that we don't have to study. This is something that we don't have to study. This is something that we don't have to study. This is something that we do have to study, and this is what is known as MLE. Now, इस चीज़ का मतलब क्या है कि something that maximizes the probability of observing the sample that we did observe. Basically, कि let's get back to this example, right? Ki I am trying to estimate this size of the petal. Now let's say I know the size of the petal is uniformly distributed. ठीक है. What does it mean कि the size of the petal is uniformly distributed? It basically means that if I, let's say, collect, or if I, hypothetical scenario, if I take each and every one of these flowers, I measured their petal size and then I plot it. Okay, so let's say this is my graph. On the y-axis I am measuring frequency. On the x-axis I am measuring intervals of petal size. Right, so I have, let's say here 0 to 1 millimeter, 1 to 2 millimeter, 2 to 3 millimeter, 4, 5, 6, 7, 8, 9, 10, and so on. Right? So what does it mean when I say that I am assuming that the petal size is normally distributed? What I mean is that, let's say I take each and every one of this flower, I measure the petal size and then I kind of count. So let's say 0 से 1 के बीच में this many flowers were there. कि इतने सारे flower, let's say this is 5. So 5 flower का petal size 0 के 1 के बीच में था. 1 to 2 के बीच में let's say इतना सारा flower था. Then 2 to 3 के बीच में इतना सारा flower था. And I plot this histogram, right? For every, I kind of do this for every flower, and I'll get some histogram like this. And let's say this is where the majority of the flowers have petal size from 4 to 5 millimeters. Then it starts to drop, right? So it looks something like this. It should look something like this. I'm sorry, I'm really particular about drawings. Please just hold on with me. Right, so let's say this is my entire histogram. So I went out there, I measured the petal size of every flower, and I kind of came up with this histogram. Now what do I mean when I say that I am assuming this distribution of petal size is normally distributed? What I mean is that कि ये जो histogram है, as I collect more and more samples or bigger and bigger samples, this histogram will start to look something like this. Right? So maybe let's say if I collect a very small sample, then it may not look something like that. Let's say if I collect a very small sample, it looks something like this. And it doesn't look really normal, right? It is more of something like this. But as I collect bigger and bigger and bigger and bigger samples, my histogram will grow, and in the very long run it will start to look more and more normally distributed. This is what I mean when I say I am assuming that the petal size is normally distributed. This is what it says. This is what it means. Now coming back to here, so what is an MLE? MLE is the guess that will maximize the probability of observing the sample. So let's say I do observe a sample of this. So 5 millimeters, 6 millimeters, 10 millimeters, 5 millimeters, 6 millimeters, 4 millimeters. And I am assuming, so this is basically I have my random variable x. What is my random variable? This denotes petal size. right? Now this is my x1, this is my x2, this is my x3, this is my x4, x5, x6. So each one of these are a random variable. Each xi I am assuming each of these xi's are normally distributed with, let's say, mean I don't know, sigma square I don't know, right? Now what is the probability, what was the probability ki x1 jo so x1 can take any values, right? This is a normal variate. Normal variables can take any values between minus infinity to plus infinity. So what is the probability that x1 will take this particular value 5? What is the probability of that? What is the probability that x2 I'll come to that. It should be 0, but it is not 0, and so on, right? I do this, I kind of calculate this probability for each and every one of these x's. Now as Tushar said that this should be 0. Why did he say that this should be 0? Because x is a continuous random variable, and the probability that a continuous random variable will take some particular point, that is 0. That is why we always ask the question ki what is the probability that x1 will lie in a particular interval. We never ask the question what is the probability that x will take a particular value. This we never ask this, because this is always 0. We always ask this. But यहाँ पर when we are kind of measuring that, what we essentially mean is this. What we essentially mean is that ki what is the probability that x, so this is just kind of a notation. What we actually mean is that what is the probability that x1 will lie between 5 plus epsilon and 5 minus epsilon, where this epsilon is very small. This is implicitly what we mean. We do not mean कि x1 का particular value 5 क्या होगा. We do not mean that, because that is 0. Continuous variable का कोई एक particular value हमेशा 0 ही होता है probability. So when we write this in this particular context of deriving the MLEs and etc., what we mean is this, कि what is the probability that x1 will lie in some interval. So this is not 0, but yes, in any other case, if someone asks you what is the probability of a continuous random variable taking a particular value, you should close your eyes and say 0. Hey, Sugata sir भी ऐसे ही बोलते हैं 0. Anyway, so this. So for the time being, assume I have calculated this for each and every one of this. Now what is, I want to kind of ask the question कि ये जो random sample मिला मेरे को, ये पूरा रैंडम सैंपल मिलने का प्रोबेबिलिटी क्या था कि x1 5 वैल्यू लेगा, x2 6 वैल्यू लेगा, x3 10 वैल्यू लेगा. इट इज जस्ट ईच एंड एवरी वन ऑफ दिस इंडिविजुअल प्रोबेबिलिटीज मल्टीप्लाइड विथ ईच अदर, राइट? ये समझ में आया? नहीं, जॉइंट प्रोबेबिलिटी. हाँ, राइट. सो द प्रोबेबिलिटी कि मेरे को ये पर्टिकुलर सैंपल देखने को मिलेगा, दैट इज दिस प्रोबेबिलिटी, एंड वी कॉल दिस थिंग एज आवर लाइक्लीहुड फंक्शन, which is most often denoted as this, fn of x given omega. Omega is basically for all the parameters, and x is basically these x's. Now if we use the density function of the normal distribution, we will get 1 by, what is this, ये हम लोग को मिलेगा 2 pi sigma e to the power minus half. So यहाँ पर this small x1 is 5, small x2 is 6, small x3 is 10, right? So this probability is x1 or 5 minus mu by sigma ka squared. This probability would be 1 2 pi. I guess I am writing this PDF wrong. I don't know. Maybe कुछ इधर उधर हो सकता है. I'm not very sure about this. ये pi शायद भीतर होता है. Wait. Wait just a sec. Need to. Pi sahab. Did I just forget the normal का density? हाँ 2 pi sigma. हाँ sigma सी गलत लिखे हैं. Is 2 pi sigma. It is. I am writing this wrong. So it is actually sigma under root 2 pi. Sigma under root 2 pi. इधर पे e to the power minus half. यहाँ पर what is the, यहाँ पर x2 का वैल्यू 6 है तो 6 minus mu by sigma whole square and 2 pi e to the power minus half. यहाँ पर 10 minus mu by sigma whole square and so on, and finally I will have this, right? So sigma 2 pi e to the power minus half 4 minus 10 by sigma, sorry not 4 minus 10, 4 minus mu by sigma whole square. So this is my entire likelihood कि I will observe this particular sample. I do not know what this mu and what is sigma is, क्योंकि mu और sigma क्या है? Mu and sigma is the population parameter. I do not know what they are. I am trying to estimate what they are. Right? Now the question that I am asking is, for what value of mu and for what value of sigma this entire expression is the highest. Is that clear? So that is the question that I am asking. Because what is Lagrange लगाने की भी जरूरत नहीं है, because we don't have any constraints here, right? So it is just simple plain and vanilla maximization problem, unconstrained. But the thing is, this is थोड़ा difficult to do in this form. So what do? We take log. We take log of this thing. So if we take log of this thing, that is known as log likelihood, most often denoted by capital L. And why we do this is because everything that is in multiplication, that turns into an addition, and finally we are going to have log of some n times log of 1 by sigma 2 pi plus minus half minus half 5 minus mu sigma square. This is something that we should get. This is something, I don't know, ऐसे कुछ मिलेगा. Now instead of maximizing this, we maximize this, because since this is a log transform, the optimum values won't change, but our job is 10 times easier doing this. And यहाँ से I do this and I equate it to 0. I do this, I equate it to 0. Why? First order conditions. And I'll get two equations. I solve them. When I solve them, I'll get some mu and I'll get some sigma as some function of xi's, right? So as some function of xi's. Actually यहाँ पर हम लोग को कोई function xi's में नहीं मिलेगा. Since we are actually using these numbers, we will get a concrete value 5, 10, 20 ऐसा कुछ solid value मिलेगा. But if we were not using this 5, 6 or anything like that, small xi's, so we'll get as some function of xi's, and this is my mu hat MLE, sigma hat MLE. That is it. So any question. So we will do a few questions and then you will see that essentially कुछ नहीं है. Likelihood function बनाना है, maximize करना है, answer मिल गया. Likelihood function बनाना है, maximize करना है, answer मिल गया. And that is all there is to MLEs. There is literally nothing else. And when do we put the cap? We put the cap for only those mu and those sigmas that satisfy this FOC condition, right? So you get these two conditions, you corresponding to these two conditions, or how many conditions you have, you are going to get a few equations, and once you solve the equations and once you solve for these mu's and these sigma, at the final step you just put a hat there, and just to denote that you have kind of used this notion of best guess. So okay, so kind of remember that this is one of the notions of making a best guess. There are other notions of making best guess. So just to kind of identify that you have used the MLE notion of making a best guess, you just write MLE here. You can choose not to write it, it doesn't really matter, but this hat matters, and hat you can just put it in your final line and you should be fine. So अब क्या समझ में आया कि what is maximum likelihood? माने do you have the overall general idea? It is okay if you are not still comfortable with problem solving. Problem solving अभी एक दो करेंगे, you will understand कि क्या है. So this is what this is. Now I just want to talk a bit more about this thing. कि what is the maximum? So पूरा same ही है कि what is the probability that the sample that I observe, उस sample को observe करने का probability maximum कब होगा. But I have some additional information about this mu's and sigmas. So for instance, let's say I know कि मेरे को कहीं से कोई एक intuition है, मेरे को कोई एक परी आकर के बोल दी कि जो average होगा वो 10 के करीब होगा, ठीक है. वो आकर के मेरे को बोल दी कि the mu will take the value 10 with a very high probability, and the probability that it is not 10, that is very low. I have this intuition with me. Given this intuition, now I want to calculate this. Now I want to calculate ki what is the probability that I observe this particular sample. So in MLE, I do not have that extra information. In this notion, I have that extra information. I try to incorporate that into my analysis. And when I do that, I get maximum a posteriori, maximum a posterior MAP estimate, most often abbreviated as MAP, maximum a posteriori. This is there in our D group but not in our syllabus. No need to worry about this. Just बोल के रखें कि ऐसा भी कुछ होता है. And that is kind of all there is to MLEs yet. So this is all there is to 7.5. ठीक है. So all of this was basically 7.5.
जो इतना सब कुछ कराया था स्लाइड में 3-4 लेक्चर्स में क्या था?
Ma'am discussed a few examples. That is what we are going to do now. Not even examples, we are going to do exercises.
पास्ट ईयर वगैरह तो डिस्कस करेंगे?
No, past is अभी तक नहीं लिया, लेना है यार, लेना है. Just a sec. So ये तो solutions हैं. Right. So यहाँ पर what I am going to do, I am not going to discuss all of them. I am going to discuss the difficult ones, few difficult ones, not all of them, and you should try the rest of them. I should do this one. 8. This I'll do right now. Suppose is a random sample from exponential distribution. Okay, let's do this for the fun of it. What else can we do? टू इजी है, ये खुद से कर लेना. सपोज what is the known theta lies in the open interval so that the MLE does not exist if every observed value is 0 and 1. This is also easy. हाँ मतलब करने लायक कुछ है नहीं, बस इंट्यूशन देना है. You should be able to do this. I should discuss this too. Question number 8. Yeah, I said I'm going to do this. I said this is something. Question number 13 मतलब easy है, but it's very 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 lengthy. Like 100% sure exam में नहीं आने वाला है. And I'll do this one. This was interesting. थोड़ा सा fun. And this one you should try. This one you should try because and so in uniform का MLE करने के लिए there is थोड़ा सा झमेला. But since ma'am had discussed that, so I'm assuming after we are done doing these problems, we should be able to, you guys should be able to do this. मतलब जो ma'am discuss कर चुकी हैं already. So ma'am had already discussed 10 and 11. Some form of 11, not precisely 11, but some form of 11 ma'am has discussed. 10 exact 10 question ma'am has done in class. In it you will find it in our presentations, I'm sure. What we are going to do is we are going to do 7, 8, 9, 12. So let's start. Let me take a picture of this question. ठीक है भाई, आपको कोई प्रॉब्लम नहीं है, हम जाके चाय पी लेंगे. So should we take a 5 minutes break, everyone? I'll take that as a yes. भागो. Okay. So 5 मिनट. हाँ, अभिषेक नायक. No. Okay. Ruby doesn't want to take a break, but most of us do. So let's take a quick 5 minutes break, and we'll continue from 5:25. 6 मिनट का break. Ruby, if you are here and if you have like any specific doubts except this, then you can ask right now. So you can do that.
सुनो करें
हाँ बाकी सब आ गया क्या? रूबी, वंशिका, okay, Ruby, yep, okay. So let's start. Okay, I'll stop this. Just a sec. So, so let's start with a few of these examples, right? So this is one of this. I should hope is one of the like not very easy but not very difficult also. This is a very good example. So solution, right? So given that x1, x2, xn is a random sample from the exponential distribution. So first of all, what is an exponential? So what I know that x1, x2, xn follow exponential distribution with parameter beta, right? And they are all IIDs. So the better way to write this would be like this. We follow IID exponential. That means f of kind of fi. Someone texted. Just a sec. Okay, so Ruby just texted me likelihood function fn, the problem that I'm having to write that particular where to take product of all or where do you take the summation. Okay, so okay, can you just give me a thumbs up if I am getting your doubt clearly? So Ruby is asking that so you are having doubt ki when should we take the product and when should we take the summation, right? Is that your doubt? Okay, okay. So that is okay. So I guess this will be very clear from this example. So anyway, so in this question it has said that x1, x2, xn is a random sample. Each xi follows a exponential distribution with parameter beta. We do not know what this beta is. It's a parameter. We need to estimate that. So we need to come up with an estimator for beta. So fi of this, right? So this basically means ki what is the PDF of xi? It is just what किसी को पता है क्या? Beta e to the power minus beta x, I guess, for all x that is positive and 0 if it is otherwise, right? Can someone verify this? Is it? Wait, I mean I guess you can write it, but exponential distribution PDF, right? So lambda it is. So what you are talking about is, yes, it is the same kind of thing. It doesn't really matter. So what, I guess that was one Shiva. I don't know.
gamma distribution को build up alpha value of gamma alpha.
हाँ, ठीक है, मतलब so just a detour की exponential को sometimes we write it as this. In this case the expectation of x would be 1 by beta, and if you write it as 1 by beta expectation e to the power x by beta, if you write it like this, then the expectation of x would be beta, right? So it's just a matter of convenience, doesn't really matter much. Anyway, so point being, so let's do it like this anyway. And right, so let x1, x2 be the observed sample. So I am writing a lot of details here. I won't be doing that for every question. So I mean, these things will stay the same for every question, right? For every question that you do. So if this is my observed sample, this is my observed sample, x1, x2, these are numbers. x1, capital X1, capital X2, capital Xn, they are random variables, they are some functions. These are numbers. And if this is my observed sample, then my likelihood function, let fn of x given the parameter beta be the likelihood function. Now fn given beta is always f1 capital X1 this multiplied by, so Ruby, take note of this, likelihood function is always multiplied. I mean x2, what is the PDF of x2 and what is the probability that it takes this particular value small x2 times, and you do this for every random variable and you get fn, what is the probability xn this takes this value xn. You never add it, you never ever add it. This is your likelihood function, right? And if you do it like this, then now you just put the values from here. इसका क्या होगा, इसका होगा बीटा e to the power minus beta small x1 times beta e to the power minus beta small x2 times, and so on till beta e to the power minus small beta xn, which is equals to, so I have n betas here, so I have beta to the power n, beta to the power n, right, because I have n betas here, so 1, 2 and so on till n. So I multiply all of them, I get beta to the power n times e to the power minus beta x1 minus beta x2 minus dot 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 minus beta xn. I have this. Do I have space here? Yes. So I have ultimately this. Anyone has any doubt till now? अगर है तो unmute yourself so I'll know, or I can also look. No doubt, right? Okay, no doubts. Right, so this is my likelihood function. Now I want to maximize this, but the problem with this is it is very ugly. I cannot maximize this, मतलब इतना आसान नहीं है. So what I do, I take the log likelihood function. What I do, I define this capital L. What is capital L? Capital L is log of fn of x given beta. I do this. Now when I do this, I will get log of beta to the power n e to the power minus beta summation xi, right? Which basically, since this is log, I can take in whatever this into is, it will become plus. So again, take note of this. Here is where the summation is coming. The summation is coming because we are applying the properties of a log, right? So this is essentially log of beta to the power n plus log of e to the power minus beta to the power summation of xi, and log of beta to the power n, it is just n log beta, right? So this is n log beta, and this is okay, so this is log base e. Okay, this is the natural log. We are taking the natural log, right? So this is the natural log. So since natural log of this, I'll even break it down further. So what we should get, okay, so let's just move this niche, because I thought I would be done in this much, but anyway. So what I would get here is essentially this. So n log of beta, this entire thing will come down, so I'll have minus beta summation xi, I running from 1 to n, and log of base e to e, right? So this is just 1, log base e is 1, so we don't write that. Now we maximize this is much easier to maximize. So first order condition implies dl by d beta, we are maximizing this with respect to beta, right? Because beta is the only unknown here. Since xi's were actual numbers, summation of xi is also a number that is known, it's a constant. This should be equals to 0 if I apply the first order condition. So if I differentiate, I am going to have n by beta minus summation xi, and this should be equals to 0. This basically implies, so if you kind of take this there and do everything else, what you will get beta equals to 1 by x bar. This is what you will get. माने I hope you can kind of imagine, इसको इधर लेके गए and if you take, then you take n नीचे, तो it will be summation xi by n, and then you reciprocal on both sides, so beta will be 1 by x bar. Summation xi by n is x bar, and at this point you need to write beta hat MLE. So this is my answer essentially. Right, I'll just do that.
एग्जाम में सही में इतना ही आएगा?
हाँ,
इतना ही था?
बस भाई मार्क्स के लिए ना खदान है, खदान, गोल्ड माइन.
हाँ भाई, ऑब्वियसली.
This was question 8, right? No, this was question 7, right? So no, this is, हाँ, so see, this is the answer. Beta hat is n by y, which is, वो लोग y लिए, they have taken summation xi to be y, there's no need to do that. So beta hat is just 1 by xn, which is what we got, right? So beta hat is 1.
मैंने भी यही किया था, मैंने भी summation
Right, so same thing, you can do it, you cannot do it, matter of convenience. So this. Now the problem will come in questions like question number 8, where you cannot इतना आसानी से differentiate नहीं हो जाएगा. So that is a bit problematic. Let's move this somewhere else. So let's look at question number 8. First of all, we need to show that whatever this is, it won't have a MLE. So let's first do that. So again, so now I won't be writing this much. I will directly construct the likelihood function. Likelihood function would be f of x1 given small x1 times f of x2 takes the value small x2, f of xn will be small xn, and I just put the formula of PDF here. So this will be e to the power theta minus x1 times e to the power theta minus x2, and so on, e to the power theta minus xn. Okay, so जहाँ पर like they have told you कि theta will not exist, I need to show that. But suppose they have just, वो लोग बस बोल दिया होता कि find this, कि मतलब कौन सा value of theta will maximize the likelihood, you just need to find that. Then how would you even know कि MLE won't exist? So let us assume कि अभी तक का हम लोग जो भी सम कर रहे हैं, हम लोग ये सोच के कर रहे हैं कि MLE एग्जिस्ट करेगा. So let's just proceed like that. So what do we do? ये सब किए and then it is basically e to the power summation of theta minus xi, where this is theta is just a constant, so what you will have is e to the power n theta minus summation xi. Nice. You see, you do the next thing, you take the log likelihood. Log likelihood is capital L, which is log of f of n, which is just log of this thing, and again natural log. So natural log, this is basically just 1, ये जो इंडेक्स में है वो नीचे आ जाएगा. So you have n theta minus summation xi. So this is your likelihood function, L equals to n theta minus summation of xi, and when you differentiate this you face a problem. This is my first order condition. So this is just n and this is a constant, right? Summation xi. So this is 0. So n minus 0 equals to 0. This will give you n equals to 0. कोई मतलब नहीं बनता है इसका. So when you get something like this, कोई मतलब नहीं बनता इसका. You had to find something theta, right? Theta तो है ही नहीं, theta तो गायब हो गया. Then you kind of know कि MLE won't exist, or there is some problem in it. Then what you should do? Then you should take a step back and then you should think for a few seconds. I won't erase this because it is there. What to do now? इसको इधर ले आना, इसको इधर ले आना. So let's try plotting this, right? Because what do we want? We want to maximize this L, right? So we just need care about that. So let's try to maximize that, draw that. This is my a linear function है, and you can kind of see कि इसका क्यों MLE exist नहीं करेगा, क्योंकि linear function है, it is linear in theta. तो straight line आएगा. Straight line का कभी maximum होता है क्या? नहीं होता है, right? So if you, let's say if you have a straight line like this, does this straight line have a maximum? नहीं. The smaller the value of x you take, the bigger the value get. So that is the kind of intuition here. So let us try to figure out what is going to be the intercept. So यहाँ पर we are measuring likelihood, यहाँ पर we are measuring different values of theta. So when theta is 0, L is summation minus summation of xi. So this, and when this is 0, theta is somewhere here, summation xi by n. So this is my likelihood function. Okay. Now why doesn't this exist? Now basically look at the question. Look at what are the values that x can take. For every value that is greater than theta, x should be greater than theta, right? X should always be greater than theta, and for every value which is less than or equals to theta, it is 0. Now so what is the value that theta can take? Theta must be, so यहाँ से क्या आता है कि theta must be the minimum of, actually not even equals to, theta must be less than the minimum of x1, x2, xn, right? थीटा इन सभी xi's में से बड़ा नहीं हो सकता है, इक्वल्स भी नहीं हो सकता है, क्योंकि यहाँ पर स्ट्रिक्ट इनइक्वालिटी है. Each x must be strictly greater than theta, right? So x1 is strictly greater than theta, x2 is strictly greater than theta. So if I put all of them together, then what will I get? कि इन सब में से जो मिनिमम होगा, theta is also less than that, right? Now let us assume without the loss of generality कि some xj which lies here, this is the minimum of xi's. तो this, right? Now any theta, any value of theta which is, so theta should be strictly less than this xj. So if xj is the minimum of x1 x2 to xn, then any value of theta such that theta is less than xj is valid, right? It should be strictly less than xj. मतलब वो यहाँ हो सकता है थीटा, यहाँ हो सकता है थीटा, यहाँ हो सकता है थीटा, मतलब there are infinity of values because so there are I mean, so this dotted line is your constraint, right? Theta can't be greater than, theta can't lie to the right of this. I guess I did this, I have already done this somewhere. Where did I do this? I have done this. Statistics, MLE, right? I have done this, I guess, here. This, right? So kind of this is the minimum value of that. All of these values that are right, all those thetas aren't allowed because tab theta will become bigger than some xi's. In fact, theta equals to minimum of these. That is also not allowed. क्योंकि तब theta will be equals to some xj, right? Where xj is the minimum, and it can't be equals to any xj. So theta can't even be this point. It can be every point which is less than this, and there are infinity of such points. Therefore, there are infinite number of possible values, and none of them are MLE. Is this clear? Huh? Okay, Ruby, is this clear to you? You can either text or unmute, whatever. Okay. Now the question is, so the second part is determine another version of this PDF of the same distribution for which the MLE of theta will exist. ठीक है? Now यहाँ पर प्रॉब्लम क्या हो रहा था? तो यहाँ पर since theta should be strictly less than minimum of all this, that was creating the problem. Now what should I do so that this MLE will exist? What I need to do, I actually need to maximize my likelihood, right? So given this constraint ki theta cannot lie to the right of this dotted line, given this constraint, I need to maximize my likelihood L. Now कोई ये बोल ही सकता है कि I should choose this particular value of theta, right? क्योंकि ये constraint, जब ये constraint दिया हुआ है तो I can just pick this particular value of theta, so my likelihood is maximized. I cannot pick this theta because there are some xi's which is bigger than which is smaller than theta, so I cannot choose any theta that is here. I can choose a theta that is here, but then I can choose another theta that is to the right of this, so that likelihood is bigger on this particular point, right? I can always do that. So if I keep doing that, ultimately I will end up at this particular point. At this particular point in the sense where I am talking about the minimum of xi's. That wasn't allowed earlier क्योंकि यहाँ पर strict inequality था. Theta should have been strictly less than the minimum of all of this. Now अगर हम वो restriction को हटा दें, if I just say that theta can be less than or equals to this, then this particular value of theta becomes allowed, and that would be my MLE, right? So to make sure that the MLE does exist, all I need to do is make this a weak inequality and make this the strict inequality, and that is it. And in this case, the MLE theta hat MLE would then become the minimum of x1, x2, xn. That is it. Is this clear? Wait a second. Is this clear? Tushar? Okay. So this was question number 8. So मैक्स टू मैक्स इतना ट्रिकी आ सकता है क्वेश्चन, इससे ज़्यादा ट्रिकी नहीं आएगा. दिस इज मतलब द मोस्ट ट्रिकी दैट यू कैन से. एंड मेरा तो अभी स्टार्ट नहीं हुआ. आई एम जस्ट होपिंग कि तुम लोग के साथ स्टैट रिवीजन करते करते मेरा स्टैट भी रिवीजन हो जाएगा. बहुत कोई का मैथ्स में भी डाउट है, सो आई एम थिंकिंग कि साथ में मैथ्स भी कर लेंगे तो मैथ्स भी रिवीजन हो जाएगा. माइक्रो भगवान भरोसे है.
हाँ.
तो सो बाय द वे नेक्स्ट आई एम थिंकिंग कि नेक्स्ट वीक आई एम गोइंग टू काइंड ऑफ ऑल्सो डू स्टडी, ग्रुप स्टडी विथ मैथ. तो अगर किसी का मैथ में डाउट होगा तो बता दियो. तुषार तू तो बोला ही है, तो तेरे साथ तो बैठना ही है. रूबी यू हैव ऑल्सो सेड, सो विल डू मैथ टुगेदर एंड आई एम होपिंग कि हम लोग का सबका साथ में मैथ्स भी हो जाएगा. एंड स्टैट्स का भी पार्ट है.
माइक्रो मतलब एक बार पहले का पीएस में पढ़ा चलता है. हम लोग थोड़ा स्टार्ट से सारे के सारे वो हो जाएंगे ना, ये नाम भी आ गया. एक बार एलए का पीडीएफ खोल के मेरे को मैं एक क्वेश्चन पूछता हूँ.
रुक जा, पहले ये डिस्कस करके ख़त्म कर लेता हूँ, उसके बाद कर लेंगे. सो आई एम गोइंग टू डू दीज टू वेरी क्विकली. ठीक है. Again, so this is my PDF. Find the MLE, right? So what is what is the likelihood function? The likelihood function is, I am not going to even write sab kuch. I am directly going to write this. It is going to be theta to the power n x to the power n theta minus n, right? Huh. This is going to be my likelihood function. I am going to take the log likelihood function, which is going to be n log theta plus n theta minus n log of x. Okay. I guess Tushar left, his phone is dead, he'll rejoin. Anyway, so this is my log likelihood function. How do I maximize this? I just take the derivative with respect to theta, I equate it to 0. This is my FOC condition, right? And if I do it, what will I get? I'll get n by theta plus यहाँ पर क्या मिलेगा? I'll get wait a sec, I did that. Okay, so this is why you should not jump steps, and no matter how tired you are, no matter how everything you are, you should always do every step. I made a mistake there, so this time I am going to write everything. So the log likelihood function is f1, x1 takes this particular value, x takes to this particular value, and so on. हाँ, हेलो. बाय द वे तुषार, वो जो कर रहे थे वो गलत हो गया थोड़ा, तो आई एम डूइंग इट अगेन. this particular value. So I just put these values: theta x1 to the power theta minus 1, then theta x2 to the power theta minus 1, so on till theta xn to the power theta minus 1. Then I get theta to the power n. Then I get this x1 times x2 times xn whole to the power theta minus 1, right? So this is what I get. I पहले जो लिख रहे थे that was rubbish, that was wrong. So this is what you get. And then you take the log likelihood function. I am not going to write log of fn, वो तो implied है. You will get n of log theta plus theta minus 1. Then you get log of multiplication of all of this. So that is essentially the summation of log of xi, right? Again, Ruby, don't get confused. This is just from the properties of log, right? So this has nothing to do with कब multiply करना है, कब sum करना है. To get the log, to get the likelihood function, you always multiply. You never sum. And once you take the log, by the property of log function, everything breaks down in nice summations. Now FOC implies del L by del theta should be equals to 0. This will give me n by theta plus theta minus 1. नहीं, theta minus 1 नहीं, it will be plus summation of log of summation of xi 1 to n. This should be equals to 0. Right, and from here if you isolate out theta hat MLE, you will get minus n by summation of log xi. This is my final answer. I don't like red, I like green. This is my final answer. So this was clear? If not, then let me know. If yes, then don't need to say anything.
ये समीकरण अंदर नहीं होगा, लॉग इसके के बाहर
लॉग ऐसे के बाहर नहीं होगा ना, क्योंकि यहाँ पर भी टुक द समीशन है ना, तो यहाँ पर भी टुक द लॉग. सो इट वुड बी व्हाट, लॉग ऑफ थीटा टू द पावर n प्लस लॉग ऑफ सबका सम टू द पावर थीटा माइनस 1. ये यहाँ पर आएगा. अंदर ये करने में बहुत मजा आता है. Anyway, तो now this question, this is again a bit tricky but essentially कुछ नहीं है, फालतू का माथा खा रहा है और कुछ नहीं. So this question is very what to say, मतलब भाई बहुत easy है और कुछ नहीं. So यहाँ पर क्या बोला, there is a large population which contain k different types of individuals, right? So let's say entire DSC का class, there are what to say, there are people from Delhi, there are people from Haryana, there are people from Calcutta, there are people from Ghaziabad, Faridabad, there are k types of people, and theta I is the proportion of individual from type I, right? So let's say 5% of the people are from Kolkata, so theta k is 0.05. 10% are from, let's say, Tamil Nadu, so theta t is 0.1. 80% are from Delhi, so theta d is 0.8, like that. Okay. Obviously, if I add all the thetas, I should get 1, and I have a random sample of n individuals. Okay. N1 denotes the number of people of type 1, N2 denotes number of people of type 2, Nk denotes number of people of type n. So what is the MLE of theta 1 to theta k? Now there are two ways to do this. One is the way that is explained in the book. I will discuss that, I won't do it again. I have मतलब वो लिखा हुआ है मेरा, so I'll just discuss it from there. There is another way of doing this which is much easier, much intuitive. and I'll discuss that. So what I do is I define my random variable let x I j be a random variable such that xij is 1 if ith in, so this is I, individual DUL is of type j and 0 otherwise, right? Now let yj be equals to summation of xij's. This is j, this is I running from 1 to n. So what I am doing, मेरे पास n people है and my sample would look something like 1 0 0 0 1 0 0 1 ऐसे करके, right? And this is 1 मतलब पहला individual jth type का है, चौथा individual jth type का है, right? So if I add all of them up, I'll get total number of people from jth type. So I am defining that to be yj. Now if your part A is clear, then I hope you will be able to understand that yj is basically a binomial distribution, binomial, right? So each xi is a Bernoulli distribution, and when I add them up, it's a binomial distribution. So each xi is Bernoulli theta j, right? Each xi is theta j. Bernoulli each xi follows Bernoulli distribution with parameter theta j. But when I add them up, acha, why theta j? Because this is the proportion, right? Theta is the proportion of individuals of that particular type. So this basically gives me my probability कि कोई एक particular बंदा jth type का होगा. So anyway, so when I add all of these xi's up, I get a binomial distribution with parameters n, because there are total n individuals, right? And this my theta to be the probability, तो np लिखते हैं ना, binomial np लिखते हैं, so that p is theta j. Now what is my likelihood function? My likelihood function is that कि out of this n people, what is the probability that exactly nj people are of type j, right? So actually this is fn, right? So fn of x given theta, that is essentially कि exactly so this is exactly मतलब this is exactly equals to the probability that exactly nj people out of n people are of type j, and you just put this in the formula of binomial distribution and you will get out of n people we are choosing nj people, and I have got theta j to the power nj and 1 minus theta j to the power n minus nj, right? Now I take the log likelihood, I take log on both sides, I will get log of nj, which is just a constant, plus nj log of theta j, and here what will we get? We will get n minus nj log of 1 minus theta j. Now we maximize this, so FOC. तो अच्छा, बाय द वे फॉर ईच यहाँ पर हर एक जगह लिखना पड़ेगा फॉर ऑल j is 1 2 dot 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 k, because we are not doing this for a particular j, we are doing this for every type of individual, right? So this is a generalized case, but we will do this for 1, we will do this for 2, and we will do this for k. सो ईच एंड एवरी जगह यहाँ पर हर एक जगह लिखना पड़ेगा फॉर ऑल j is this, j is this. If you don't write it, if the professor is थोड़ा सा strict about notation, they can take away 1 or 2 marks. I don't know. So you differentiate this with theta j, and what will we get? This is a constant. This will be 0. यहाँ पर we'll get nj by theta j. यहाँ पर what will we get? We will get 1 minus theta j. Then we'll differentiate अंदर का this, so we'll get -1, and ये तो बाहर एक constant है ही, so we are going to have n minus nj. This should be equals to 0. From here we can do this, right? Nj by theta j equals to n minus nj by 1 minus theta j. This gives nj minus nj theta j, which is equals to n theta j minus nj theta j. This cancels out, this cancels out. Finally, what do we have? We have theta j hat to be nj by n. This is for all j 1, 2 to k. Right? So this is one way of doing this. And you can verify this is indeed the answer that they have in the book. And this is exactly equals to, मतलब अगर you have, so after let's say when you try these questions by yourself, you will find that this question number 2 is exactly the same as what we did just now. ठीक है? So someone texted me strike sheet. This particular sub क्या हुआ है? This particular exercise. So what I was saying. हाँ. So when you do this question number 2, you will find that whatever that we did right now exactly similar है. ठीक है? Now what they have done in question number, so what they have book में क्या किया हुआ है, that is something that I want to discuss थोड़ा सा, but yeah. So I mean this is a bit less intuitive than what is there in the book, but this is easier. And what they have done in the book is basically this, I guess. Yeah, this. So right. So in the book वो लोग क्या किया है, वो लोग बोला है कि okay, so what is the probability that out of n people exactly n1 people are going to be of type 1 and 2 people are going to be of type 2. It is just this thing, right? If you can remember, this is the multinomial coefficient. In the book they have just ये चैप्टर 2 या 3 में था, कहीं एक था मल्टीनोमियल सैम्पलिंग विदाउट रिप्लेसमेंट था. एनीवे उतना रेलेवेंट नहीं है. बुक में दे हैव नॉट इवन मेंशन्ड दिस. दे हैव डायरेक्टली रिटन कि लाइक्लीहुड फंक्शन इज थीटा 1 टू द पावर n1, थीटा 2 टू द पावर n2 एंड डॉट 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 थीटा k टू द पावर nk. उन लोग इसको लिखा भी नहीं है. क्यों नहीं लिखा है? बिकॉज व्हेन यू टेक द लॉग एंड व्हेन यू डिफरेंशिएट, ये ऐसे भी वैनिश हो जाएगा क्योंकि दिस इज अ कांस्टेंट, गायब हो जाएगा, फर्क नहीं पड़ता है. बुक में वो लोग बस ये लिखा है. I hope you understand why, because n1 people, so what is the probability that this particular person is of type 1? That probability is theta 1. Now I have exactly n1 of these people, so ऐसा पूरा out of पूरा n sample में ऐसा I will get n1 times theta 1, so I group them together and I get theta 1 to the power n1. Similarly all of this, I take the log, I get this. Initially I get this a is basically log of this constant, doesn't matter, and then you get this, right? हर एक log of theta 1 to the power n1 plus log of theta 2 to the power n2, सब ऐसा अलग हो जाएगा. Then all the n1s are going to come in to the beginning. Ultimately you will have this, and then इसको ऐसे if you expand it. Now what they have done is they have used the fact that theta summation of theta I is 1. It is given in the question. So the kth term theta k, they are writing in terms of this. Okay. So instead of writing theta k, so इसका मतलब क्या होता है? इसका मतलब होता है theta 1 plus theta 2 plus theta k is equals to 1, right? So इसका मतलब theta k का वैल्यू क्या है? 1 minus theta 1, theta 2, theta k minus 1. That is exactly what they have done. The summation runs from I to k minus 1. Now they have differentiated this. So let's say we differentiate this with respect to theta 1 and equate it to 0. What will we get? ये a पूरा vanish हो जाएगा because it's a constant. यहाँ पर we are going to get n1 and theta 1 log of if you differentiate log of theta 1 is just going to get to the denominator. ये सारे के सारे vanish हो जाएंगे because यहाँ पर theta 1 है ही नहीं. theta 1 और कहाँ है? theta 1 यहाँ है, right? So we differentiate this. So n के रहेगा log of this, log के भीतर जो भी है सब नीचे आ जाएगा, and then I have summation of these theta i's. So when I differentiate each one of them, सारे के सारे वैनिश हो जाएंगे, बस थीटा 1 डिफरेंशिएट होगा और उसको डिफरेंशिएट करके मेरा 1 आएगा, और सिंस यहाँ पर एक माइनस साइन है, इट आई eventually get minus 1. Then I do this, right? I again write this as theta k, right? Because I can write theta k like that, and then if this is equals to 0, so I'll get n1 by theta 1 is equals to nk by theta k. This will be for everything. तो n2 का भी यही आएगा, n3 का भी यही आएगा, n4 का भी यही आएगा. So ultimately I am going to have this. After I have this, what they have done in the book is they have assumed that this is equals to some alpha, right? So they have assumed that that is equals to some alpha. Then each theta I, so each I can express then each theta I as ni by alpha, है ना? थीटा को यहाँ से I can write कि n1 by theta 1 equals to alpha. तो यहाँ से we can write कि theta 1 is n1 by alpha. So I can write that for every theta I. Again, if I sum up all the thetas I should get 1. So if I sum up all this ni's by alpha I should get 1. यहाँ से I find the value of alpha, which turns out to be n. तो इसको if I put here, I finally get my MLE. तो alpha की जगह n बैठा दिया, I get the same answer. I get the same answer, ni by n, which is exactly what we got here. So nj by j, right? So I hope both the methods were clear. This is the maximum kind of trickiness that you can expect. इससे ज़्यादा और कुछ tricky आएगा नहीं. I should rename this as stat study group sessions. That is it. I don't think any one of us wants to proceed with 7.6 now. 2 घंटा हो गया है, किसी का और सर काम नहीं करेगा. So we'll do this on a weekend. On a weekend क्या? यही weekend कर लेंगे. And this is comparatively छोटा.
इसके बाद और कितने 7.7
7.7 7.8 I'll just have to check कि मैम ने वहाँ से, इसीलिए I wanted the PDF कि मैम ने वहाँ से, because वहाँ पर इतने सारे कुछ नहीं करना है, इतना सारा कुछ just नहीं करना है. We don't have this much. We have a few, and it's better if you want to do it by yourself. Just look at the 7.7 का, अरे यार 7.7 का just examples. Just examples should be enough, because ma'am has said it herself that examples is more than enough. Anything else would be overkill. I don't think we are going to get the time to get into each and every one of this. Just होगा नहीं. तो
part of the revision
तो ऑल्दो ईच एंड एवरी वन ऑफ दिस मैम ने डिस्कस किया था, बट आई डोंट थिंक उतना सीरियसली इसको लेने का जरूरत है. So that is it. So right. So I guess we'll I'll let everyone know in the group कि क्या होगा.
ये क्वेश्चन वाला